Hi, I'm the Adobe guy again, and today I'm going to be talking about another AutoCAD Lisp routine here. Now this one is one that's quite useful to a lot of people, particularly if you're working with cable design, and it's designed to show how you can hang cables between two pylons. Now some people think this is a parabola, and they're right, it is a parabola provided the weight of the cable is 0. If the cable actually has a weight, then it'll hang slightly differently, and that's then called a catenary curve. Okay, so let's have a look at AutoCAD. I'll show you the routines first of all. Okay, so firstly we have the catenary routine, which was written in 2001, and I've made a couple of changes to this one just so that it functions better. And you'll notice that AutoCAD doesn't have the capacity to draw a parabola or a catenary function direct. So what we have to do is we have to use the function of drawing a curve using the x and y values, and this involves some complicated mathematics, and this is the one for doing the catenary curve. And if you want it, just ask me and I'll send it to you. This is another one, hang cables, that I've just written. It's massively simplified and it's representative. In other words, it's not accurate. It's just designed to show roughly how they will hang, given a certain deflection. The deflection I've called a sag, and that's the cable sag, and that's a fraction of the x distance between the pylons, for example 0.1. So if you want the sag to be 10% of the distance between the pylons, just press enter, and that will leave it set at 0.1, which is a tenth of the distance, the x distance. And you'll notice here that my code is massively simplified, although it does still involve a little bit of mathematics. And all I've done is I've taken the midpoint between the two start and finish hanging points, and I've then added the sag, or subtracted the sag from that point. And then I've used, if you look down here, I've used an arc, a simple arc, to go point 1 midpoint, point 2, and then reset point 1 to be point 2 to go back to the start again. You notice this is the while function here, and it goes back there. So getting the first pick point is outside of the while function. So once we've started the function, it will continue on. And I've just added in exactly the same bit of code just across here in this other function, just to make it continuous, so it carries on as well. Whereas previously it didn't. And you'll notice that after getting point 1, I've then put in the while, and it gets the next point. And if we scroll down to the bottom of that one, you'll see that I've actually reset point 1 to be point 2, just so that the function can continue, and it makes it a lot more, let's say, useful. Now what I've also done in this one is I've added in some default values, and I've added in a default value for the tension of 100 and for the weight, which is weight per unit length of the cable, of 1. Now if you're doing a catenary curve, you do need to know these two things. In my routine, all you need to know is the sag, because it's not designed to be accurate, it's just designed to be representative. Okay, so we've got those two. Let's see how they work. So I'm going to first of all load them. So I'll load the applications, and I'm going to go through, I'm going to load hang cables, and I'm also going to load catenary. Okay, it tells me they're both successfully loaded. If you're not sure, just click on here and you'll see catenary loaded and hang cables loaded. Okay, let's see how they work. So I'm going to do the hang cables first. Start typing in hang, and it comes up with the hang cables command. It says enter the sag as a fraction of the x distance. Now I'm just going to press enter to use the default, which is 0.1, in other words 10%. It now says start point, so I'm going to start just at the top of my pylon, and the next hang point will be the next pylon, and the next one will be the top of the next, and so on. And when I get to the end, I just press escape or enter. Yeah. And you'll notice it's done what I think is a pretty good representation of a hanging cable. Yeah. Let's see what the catenary curve does. Now this is a much more accurate way of doing it, and this is the more correct way of doing it. I'm going to again leave the defaults. The tension of the cable is set at 100, and the cable weight per unit length is set at 1. My initial point let's just choose, and I've set up a midpoint in there, which is a node. And I actually just missed it there as well. Okay, so there you have it. That's the difference between a catenary curve and just a simple arc. Now you'll notice that the catenary curve is going to change massively depending upon the tension and the weight of the cable. Obviously the greater the weight, the more sag it's going to have towards the middle, and the greater the tension, the tighter it's going to appear, so the less sag towards the middle. There are lots of other things you can do if you want to get a real proper way of doing this, which takes into account lots of different things, including temperature, coefficient of expansion of the material you're using, the conductor. What I suggest you do is use software called SAG10. That's the industry standard software that's designed for doing this. All I've done with my routine is just basically done a little arc just to show you how it works. Just let me show you another difference between these two types of curve. The catenary curve, you'll notice, is made up of lots of different points. In other words, it's basically a polyline. The arc is an arc, so it's a much simpler function. Okay, that's all I've got for you today. I hope it's been useful. I'm the Adobe Guy, and thank you for watching.